Hello everyone. Today I want us to look at how to integrate 1 over 1 plus sine x minus cos x with respect to x. So in this kind of integral, we are going to use the t method of substitution. So we're going to say let t be equal to tan x over 2. So that is our substitution, and we need to find the corresponding differential. So I'm going to differentiate t with respect to x. So we are going to get dt over dx. That should be equal to 1 over 2 sec squared of x over 2. But you know sec squared of x over 2 is the same as 1 plus tan squared of x over 2. So this can be written as 1 over 2 into 1 plus tan squared of x over 2. And so tan x over 2 is t. So tan squared of x over 2 is t squared. So this 1 over 2 into 1 plus t squared. So we make dx the subject. So we need to cross multiply to get dx equal to 2 dt, everything over 1 plus t squared. Now we have expressed dx as a function of t. So this is another substitution that we are going to make. We also need to know sine x in terms of t and also express cos x in terms of t. So let's to be able to find those ones, we need to draw a right angle triangle, and our angle here is x over 2. Tan x over 2 is equals to t over 1. So the opposite is t, and adjacent is 1. So this is t, and this is 1. If you use Pythagoras theorem, you are going to get the hypotenuse as the square root of 1 plus t squared. So from that triangle, we can now be able to find sine x over 2. We can now find sine x over 2 from the triangle. Use SOHCAHTOA. That will give you t over root 1 plus t squared. You can also find cos x over 2 from the triangle, and that is equals to 1 over the square root of 1 plus t squared. So that if we use the trigonometric identities, we can be able to find sine x in terms of t. So remember, sine x is the same as sine x over 2 plus another x over 2. And so this should be able to give us, remember, sine a plus b. This is the same as sine x over 2 cos x over 2 plus another cos x over 2 sine x over 2, which can be written as 2 sine x over 2 times cosine of x over 2. And so if I replace this the same as 2 sine x over 2, we got t over the square root of 1 plus t squared. Cos x over 2, we got 1 over the square root of 1 plus t squared. So that our answer should be equal to 2t over 1 plus t squared if we multiply numerator and denominator. So that is sine x in terms of t. Similarly, we can find cos x in terms of t using the identity for cos a plus b. So you can write that cosine of x is the same as cos x over 2 plus x over 2, which you can write again as cos x over 2 times another cos x over 2, remember cos a plus b, then minus sine x over 2 times another sine of x over 2, which you can as well write this as cosine squared of x over 2 minus sine squared of x over 2. And we know cosine of x over 2, so we square that. That should be able to give us 1 over root 1 plus t squared. We are going to square this minus t over root 1 plus t squared. Again, we square that. So when we simplify, we should be able to get, this should be able to give us 1 minus t squared in the numerator over 1 plus t squared in the denominator. So going back to the integrand, we need 1 plus sine x minus cos x. So we'll write this. You can say therefore, I can use a different color. Therefore 1 plus sine x minus cos x, that's the denominator in our integrand, is the same as 1 plus sine x, we got there 2t over 1 plus t squared, minus cos x, that is 1 minus t squared over 1 plus t squared. So remember 1 is the same as 1 over 1. So I want to find, or simply to combine this into one fraction. So you'll find the LCM. Our LCM is 1 plus t squared. So 1 will go into the LCM, 1 plus t squared times 1. So we'll have this. We'll have 1 times 1 plus t squared, then plus 2t minus 1 minus t squared. And so in the numerator, I can open the bracket so that I get 1 plus t squared plus 2t minus 1 plus t squared, everything over 1 plus t squared. So I can see 1 will cancel with this negative 1. So we'll have 2t squared plus 2t, everything over 1 plus t squared. And you see 2t is common in the numerator. Factor that out, 2t into t plus 1 over 1 plus t squared. So now the reciprocal of 1 plus sine x minus cos x, what will that give us? So hence, you can say hence 1 over 1 plus sine x minus cos x is the same as 1 plus t squared over 2t into t plus 1. So this is what we need to integrate with respect to x. Remember, we are converting the integrand. Now our new integrand should be a function of t. So I now know the integrand as a function of t, and we also know dx as a function of t. So therefore, our given integral can now be written as the integral of 1 over 1 plus sin x minus cos x dx. If I substitute, that will give us the integral of 1 plus t squared over 2t times t plus 1, and our dx is the same as 2 dt over 1 plus t squared. So 1 plus t squared will cancel with the other 1 plus t squared, and 2 will cancel with these 2. So our task is to integrate 1 over t into t plus 1. Integrate that with respect to t. Now, for us to evaluate this integral, we need to use integration via partial fractions. Why? Because in the denominator, we have a product of two linear factors. So we need to decompose that integrand into its partial fractions. This is how we are going to do it. You say let 1 over t into t plus 1 be equal to a over t plus b over t plus 1. Remember, the numerator must be a constant because denominator is linear. When the denominator is quadratic factor, the numerator must be linear. So if I multiply this equation by the LCM, what will it give us? We are going to get a times t plus 1 plus b times t, and that should be able to give us 1. I can call this as equation star. I can call it star. So a and b are constants which we need to find. I want to use the simplest method. If I put t is equals to 0, what will I get? See, that will help us eliminate the second term on the left-hand side. So we are going to get a is equals to 1, because you substitute t is equals to 0, you get that. What about if we put t is equals to -1? What will it give us? That will help us eliminate the first term on the left-hand side of equation star, so that we are going to get -b is equals to 1, or simply b is equals to -1. So therefore, my fraction can now be written as, so this thing here, our fraction can now be written as, equal to a, which is 1 over t, minus b. Remember, b is -1, so minus 1 over t plus 1. So I want to integrate it. So our integral, look at our integral, this one. We have managed to decompose the integrand into its partial fractions. So this is what we need to integrate. What will it give us? So let me just go with it and write it here. When I substitute the partial fractions, we're going to get this. It will now be equal to the integral of 1 over t minus 1 over t plus 1. Integrate this with respect to t. And so if you integrate, the first term will give us natural log of t, and then minus the other one is natural log of t plus 1. Then there's a constant c of integration. If we use the second law of logarithms. Remember, log A minus log B is the same as log of A over B. So this is the same as log of T over T plus 1, then plus a constant C. And then you have to replace T. Remember, T was equals to tan X over 2. So this can also be written as natural log of tan X over 2 divided by, of course I can just say 1 plus tan X over 2, then plus a constant C of integration. So that is our answer of that kind of integral. It is very simple. And remember that when you are evaluating integrals where you are not given the limits of integration, you must add the constant C of integration. So thank you all for watching. Next time we look at other forms of integrals where we have to apply other techniques of integration. Bye bye.